Alrighty, so this time is on unlike denominators. Unlike denominators mean that they have different types of denominators. Who remembers how we figured out like denominators when we had just numbers? Do we add or do we multiply to make them the same? Multiply, right? So, but before you multiply, we always want to check if we could simplify before you multiply. For example, 2 over 3x plus x over x squared. Is there any, are either of the add-ins able to be simplified? Which one? X over x squared, right? So this can be simplified, leaving me with 1 over x. So let's rewrite it. 2 over 3x plus 1 over x. Then now looking at the 3x in the first add-in and the second add-in having x as a denominator, what's missing in the second one? 3. So I need to make sure I am not changing the value of 1 over x, but changing its outfit, changing the way it looks. We need an equivalent fraction. So to get that equivalent fraction, we need to multiply this by 3, but it's not going to be just 3, it's going to be 3 over 3. We don't want to change the value. If I multiply by a 1 equivalent, right, will it change 1x? Oh, sorry, 1 over x. If I multiply, will I change 1 over x's value if I multiply 1 over x by 1? If I multiply any number by 1, will I change the value? No, that's what I'm trying to get to. I just changed the outfit, the way that 1 over x looks, but I didn't change the value. Does that make sense? Okay, so we're going to rewrite this. First term is still 2 over 3x. We haven't done anything with that one. Plus 3 times 1 is going to be 3. 3 times x is 3x. Now do we have common denominator? How come I multiplied the 1 over x but not 2 over 3x?
Oh, it's because it's 1 over 1.
1 over 1? What do you mean?
Oh, I was going to ask why you only multiplied but then I realized you multiplied.
Yeah, 3x already has the x and the 3. So the only piece that's missing in the second add-in is the 3. So I just need the 3 to be there. Does that make sense? Okay, so let's go ahead and combine those. Whoever that's headphone is playing really loud music, let's turn it down or off rather. That should be 2 plus 3 over 3x, making this 5 over 3x. Anything I can simplify there? 5 over 3x? I still hear it. Take your earbuds out. I'll take it.
My earbuds?
Mm-hmm. Both.
Only have one on.
Yeah? Is it yours? Okay. Where's your case? Put it in. I'll take it first. I asked you to turn it down. You didn't even hear me. What's the problem, dude? Okay. We have this denominator right here. I'm going to erase that. Let me try that again. Okay. X plus 3 and x plus 2. How do we get a common denominator? Multiply. What? This x plus 3 needs an x plus 2, right? And this x plus 2 needs an x plus 3. We need to multiply each one with each other's denominator to have a common denominator. So here's my 2 over x plus 3 needing x plus 2 in the denominator, but I can't just multiply by x plus 2. I have to have a single value that equals to 1. So we need x plus 2 in the numerator and in the denominator. How's it going? Are you sure?
Yeah.
Ask if you're not sure. All right, then we're going to subtract the second part, x over x plus 2. And then we're going to multiply by what it's missing to make it a common denominator, which is x plus 3. So we're going to go ahead and put x plus 3. It has to be same on numerator and denominator to make it a giant 1. Now we have a common denominator of x plus 3 times a quantity of x plus 2. Okay. The numerator is going to be a little more complicated. Okay. So this is the same thing as saying 2 times the quantity of x plus 2. And then the second one is same thing as saying minus x times the quantity of x plus 3. Are we okay? What do I need to do to simplify the numerator then? Yeah, distribute. I'm going to distribute 2 to the x and 2 to the 2. Then I have 4, I jumped the gun. 2x plus 4. And then the second one will be negative x times x and negative x times 3, making it negative x squared minus 3x. Did I do my math right? I'm questioning myself now. All right, here we go. X plus 3, quantity of x plus 3 times x plus 2 are in the denominator. Any terms I can combine in the numerator? So it looks like we can combine negative 3x and 2x and nothing else. Is that right? Okay. So let's go ahead and write down what we have, which is, I'm going to put it in standard form. Okay, negative x squared. Then we have negative x plus 4 all over x plus 3 times quantity of x plus 2. What should we do next? Factor the numerator. Okay, let's see. I'm going to take out the negative a first. Okay, just so that I have a positive one to deal with, then I will be x squared plus x minus 4. I just changed all the sign. Then I need to get a product that will equal negative 4 and a sum that will get 1. Okay, I need you to walk this through with me. Product that makes 4, there's 3 factors that work. 1 times 4 and 2 times 2, right? To make a product of 4. Would any of those combinations give me a 1 whole? Positive 1. 2 plus 2 is 4. 2 minus 2 is 0, so that doesn't work. So the 2's out. 1 and 4, it's either going to be 5 when we add them or 3 if we subtract it. So none of it is going to give me a 1 as my middle term. Does that make sense? So it's not simplifiable. It's not factorable. So this is done as it is. You have to check on that. Always check if it's factorable or not. If you have to use quadratic formula in order for you to solve it, then that's not going in the right direction. Okay? It has to be factorable. It must be factorable for you to factor and simplify. Okay? Questions? Cool. All right. So there's 4 more examples that I want to go over. And it is on page 15. 15. Unlike bases. Okay? So example 1's like a giveaway. It's like so easy, it can be given away. Do we have like denominators here? Nope. So we need to multiply the first one and the second one to have a common denominator. What should be the common denominator there? 6. I'm so glad you didn't say 5. All right, so I have x over 3 needs to be multiplied by something to make 6, and x over 2 needs to be multiplied with something to make it a 6. So what are those somethings for x over 3? 2 over 2. Thank you, Leo. So we have 2x over 6. And then the second one needs what? 3 over 3. So we have plus 3x over 6. Now we can combine. Do I get 12 as my denominator or 6? 6. And then 2x plus 3x is 5x. Nothing else to simplify. We're done. Okay. Simplifying rational expression is built in and embedded in every one of the learning targets for multiplying, dividing, adding, and subtracting. So I'm not testing you explicitly on simplifying, but that needs to be part of your grade for multiplying, dividing, and adding and subtracting. Okay? So just keep that in mind. All right, do we have common denominator for example 2? Not yet. What should be my common denominator? 30. Good. Then that means that I don't have to do twice as much work and multiply both add-ins or subtractants. I forgot what they're called if they're subtracting, the pieces that are being subtracted. Which one needs to be multiplied so I can get a 30 as my denominator? The 6 needs to be multiplied with 5 over 5, right? So numerator is going to be 5 times the quantity of a plus 10 over 5 times 6 is 30. Minus. Second one should stay as is, so 2a minus 1 over 30. Now do we have a common denominator? Okay, so before I combine the two, I need to do what with each of the numerators? Simplify or distribute would be best. So let's go ahead and get that worked out. So 5 times a and 5 times 10 is 5a plus 50 over 30. And then negative times 2a and negative times negative 1 gives me negative 2a plus 1. You guys okay? Did I do too much at the same time or are you guys all right? Okay. Let me know if I did too much at the same time. Then I can write it out separately. Give me a little nod of the head if you want me to go over. Okay. All right. So let's combine like terms. 5a with negative 2a makes 3a. 50 and 1 makes 51. So that's 3a plus 51 over 30. Do we have anything else that we can simplify? How? Can I just knock 3 over 30? Not at this point. What's the GCF for the numerator? 3, then what am I left with for the 51? No way. 3 times 17 is 51? Yep. A plus 17. If you're in doubt, go ahead and multiply 17 times 3 to confirm. And then I could write out 30 as 3 times 10, if that's easier for you to see. Or you could leave it as 30. It's up to you. Okay? So now can I simplify 3 over 30? Yes. Then I have 1 over 10. Which leads me to my final answer of a plus 17 over 10. Any questions? All right, we're building ourselves up to the point where the question is more like the quiz on Tuesday. Example 4 is going to be most like the quiz. It is like the quiz. Not most likely. It is like the quiz, okay? So let's take a look at example 3. K plus 24 over 5k plus 20 plus k over k plus 4. Denominator. Do we have the same denominator? Nope. How do I make it the same? Just add pieces in there? I have to multiply to get common denominator, okay? You can't skip that option, so let's factor 5k plus 20 and see if I have something in common with the second addend, okay? So if I did that, what's the GCF for 5k plus 20? 5, thank you. So we have k plus 20, oh, not 20, k plus 4 left. Ooh, would you look at that? Isn't that the same thing? Okay, so I'm going to leave the numerator as it is, k plus 24, plus k over k plus 4. Now, what do I need to multiply the second addend to make it same as 5 times the quantity of k plus 4? 5. So I need to multiply numerator and denominator by 5. Then I get k plus 24 over 5 times the quantity of k plus 4 plus 5k over 5 times k plus 4. You doing okay? Do we have same denominators now? Yay! Then I can combine the numerator. So 5 times the quantity of k plus 4. Then we have k plus 24 plus 5k. So how many k's do we have in all? 6. So we have 6k plus 24 all over 5 times the quantity of k plus 4. Anything I can simplify here or factor before I simplify? 6k and 24 have a GCF of what, Joshua? Oh, that's such an easy question and you weren't paying attention. That's why you can't answer it. There you go. And what am I left with? K plus 4. Yay. So we have 6 times the quantity of k plus 4 over 5 times the quantity of k plus 4. What can I simplify? K plus 4. Then we get 6 over 5. Okay? You doing okay? What did you think? We're getting closer to the way that it's supposed to be on the quiz. Okay? Now this one's really like the quiz. Example 4. Okay? Do we have a common denominator? You have to ask yourself that if you see a plus or minus sign in the middle. Okay? If you see two rational expressions with a plus or minus sign, first thing you should check is, do I have the same denominator? Okay? Well, it doesn't. So let's see if there's any factors that come out of this trinomial that will match it. And see if I could minimally multiply the other one so I have matching denominators. Okay? So X box. The box isn't necessary for this one because A is 1. You can take it directly from the diamond and you can have your binomial factors and it would still be the same. Okay? But only because the A is 1. So I'm going to do it anyways because it's good habit for you. And then the side values are going to be 6. Let me try that again. 6r and 1r, where 1 is the negative. 6r, negative r. Then we have r minus 1, r plus 6. Isn't that the same? Okay. That's why if a is 1, you can use it exactly as they are. If a is not 1, you have to include the box. Okay. So instead of this, we have r minus 1 times the quantity of r plus 6, right? Then what do I need in the first one? What's missing in the first one's denominator? R plus 6, right? So I just need to multiply numerator and denominator of 4r over r minus 1 with r plus 6 over r plus 6. Is okay? I know it's getting kind of crowded in here. Okay. Then we have 4r times the quantity of r plus 6 over r minus 1 in quantity times the quantity of r plus 6. Then I'm going to rewrite this piece right next to it. So minus 28r. That one doesn't need to be multiplied with anything because we got the common denominator from that addend. Okay, so r squared is not necessary. We just need r minus 1. And I don't know how to write it. R minus 1 times the quantity of r plus 6. Now I can combine. But before I do, what do I need to do? 4r times r, 4r times 6. Okay? You guys okay? I told you it's not just one step more, right? 4r squared plus 24r. And then we have our minus 28r to come along. And then quantity of r minus 1 times quantity of r plus 6. Like terms? Any like terms? You see it? 24r with negative 28r. If I combine those, what do I get? Negative 4r. Then I would have 4r squared minus 4r, right? What's my GCF there? 4. I'm just going to, oh, one more. 4 and r. So it'd be 4r. Then I have r minus 1 as my factor. I'm left with r minus 1 times the quantity of r plus 6. Can I simplify anyone? Yep, r minus 1 over r minus 1. Then my final answer will be 4r over r plus 6.